Hello everyone. In this video we're looking at problem 623, add one row to tree. As the name suggests, what we need to do is at a certain depth in the tree, add one row, in this case all of ones. So one row where all nodes have the same value, and each original left subtree, for example this 2, 3, 1 structure, will become a left subtree of our new one node. And each original right subtree, for example this 6, 5 structure, will become a new right subtree of such a new one node. And I don't like this problem very much. It kind of seems a bit contrived and artificial. But anyway, let's look into it. And as usual for tree problems, here we can use a recursive solution and we will use a top-down approach. Okay, for all the examples that we will do, we will assume that val equals 5. The first case is where the root is null. Well, in this case, we just return null as well, because we can't do anything. Now the second edge case, let's say that the depth is 1. And this edge case is described in the problem statement. So let's say this is our tree with here the root and some left tree and some right subtree. And what we should do is here create a new node with the value and have R as the left subtree. And on the right we have null. Okay, this case was already written in the problem statement, so nothing more we need to do. Okay, the next edge case, the depth is 2. Then our tree will look like this. We have a root, we have here a left subtree, and we have here a right subtree. Let's call this L and call this capital R. Okay, let's call this capital L and this capital R. And now we need to insert at depth 2. So the left successor of the root will be a new node of value 5. And the right successor of the root will also be a new node of value 5. And now on the left we have the original left subtree. And on the right of that we have the original right subtree. And that's all for the case of depth 2. Now the final case, where the depth is greater than 2. So we have some tree, here's our root, and then we have here our left subtree, and we have our right subtree. And now we can use recursion. So basically what we can just say, we can go into the left subtree and replace it. So we keep our root, and as the left subtree, we recursively call our function that is called add one row. And we call it on the original left subtree with the same value, but with a depth reduced by 1. And this will work because then we will go down, we will reduce the depth further and further and further until we enter the case 3 again, where we have a depth of 2, and then we are done. And for the right subtree, we proceed in the same way. So also for the right subtree, we recursively call the function add one row, but on the right subtree with the same value and the depth reduced by 1. And that's it. Let's go to code. So let's check out the implementation of the cases. The first case, where the root is null, we just return null again. In the second case, which was the special case for replacing basically the root, it's also simple. We just create a new node which has the root as the left subtree. Now in the third base case, the def is 2. We replace the children of the root, so both the left child of the root and the right child of the root will be replaced by a new tree node. And finally we return the root. Now in the fourth case, we use recursion. As said in the example, the left subtree of the root will become the result of applying our function to the left subtree with the def reduced by 1. And then we do the same for the right subtree. And all left to do is to return the root. And that's it for this problem. If you liked the video, please leave a like and subscribe to the channel, and I see you in the next one.